we are going to talk about today a different way to solve quadratic equations. So, on Monday we learned two methods to solve a quadratic equation. We learned how to solve by graphing. So you graph this function, look for the point where it crosses the x-axis. Super fun, super time consuming, and you have to have a graph. Okay, we definitely don't want to solve by graphing, unless it's like a word problem or something like that. But then we learned a really simple method of solving by the square root method. Just super easy, much quicker. Not really a whole lot different than just solving a normal equation. And it would be so nice if we could use that method all the time. But we can't, okay? Because if you remember, the purpose or the whole point of solving these equations is you want it to look like x squared equals a number. And once you get it into x squared equals a number, you square root both sides and then throw the plus or minus sign on there. It doesn't always work. And here's what I mean by that. You're not going to be able to write all equations so they look like this. You're going to run across some equations where when you put the x squared and just the x squared on one side, you don't have just a number on the other side. So for example, I'm going to put that one down there. If we had x squared minus 3x minus 4 equals 0. If we tried to solve this one by the square root method, I would need this to say x squared equals, which means I need to move both of these to the other side. So I would have to add 3x and add 4 to both sides. So on the right-hand side, because you can't combine these together because one's an x, one's not an x, so you would get x squared equals 3x plus 4. And if you follow the same steps from before, to get rid of the squared, you square root both sides. Seeing the problem here? I can't solve for x. There's an x over here. That's the x I'm solving for. So what we're going to find out is that the square root method is awesome. It's super easy. We definitely want to do the square root method if we can. But if you have an x term, you can't do the square root method. Look back at those examples that we did on Monday. I had a k squared, but I had no k term. I had a y squared, no y term. See that? An x squared, no x term. A d squared, no d term. None of these had that bx. Okay? If you don't have that bx, you definitely want to do the square root method. But if you do, like the one I just showed you, we have to have another method. So, here's where we're going to learn how to solve by factoring. I know you guys are excited to bring factoring back, okay? I love this method because I love factoring. But factoring, to solve by factoring, we are going to use what's called the zero product property. And here's what the zero product property says. It says that a times b equals 0. Then it's b and b. It just means you're going to multiply two things together. So kind of think for a second. You multiplied two things together and you got 0. The only way that's possible, either a had to be 0, so that would be 0 times something to give you 0, or b would have to be 0, right, because something times 0 would give you 0, or they both would have to be 0, because 0 times 0 gives you 0. But one of them has to be 0. There's no other possible way you can multiply two things together and get 0, unless one of them is 0. Okay? So we're going to kind of use that idea to solve these equations. Okay? So the first thing we're going to do, we're going to kind of keep in mind this idea of the zero product property. The first thing that we have to do is you have to set it equal to 0. Because it's the zero product property. It's not like the one product property. It's not like a times b equals 1. Well, a has to be 1 or b equals 1. That's not the case at all. Right? It doesn't work if it's equal to 1. It has to be equal to 0. It also has to be a product. It has to be a product, meaning it has to be a multiplication problem. It has to say a times b. It has to say something times something equals 0. That's where the factoring comes in. Because if you guys remember, I drilled in your brain over and over and over and over again that factoring means multiplication. Factoring looks like that, right? You need to figure out what's going to go in the two sets of parentheses. Something times something. So I'm trying to get my problems to look like this, because this says something times something equals 0. Well, if I'm multiplying two things together and I get 0, one of those has to be 0. So you're going to set each factor equal to 0 to figure out, well, what would it need to be, and then you're going to solve. Okay, so let's do almost like that example over on that other side. So x squared minus 3x equals 4. Now, kind of like we talked about, I cannot solve by the square root method because I have an x term. If you have an x term, you cannot solve by the square root method. So we're going to solve by factoring. So we're going to use the zero product property. So the first thing, it has to be set equal to 0. This just means that everything needs to be on the same side. So that 4, I need to move it to the other side. It's a positive 4, so to move it, I'm going to subtract 4. So we have x squared minus 3x minus 4 equals 0. That's the first thing you're going to do, the zero product property. The next part, to use the zero product property, it needs to say something times something equals 0. This right now says something minus something minus something. It doesn't work if it's subtraction. It only works if it's multiplication. It has to be something times something equals 0. So to get this to look like this is factoring. Remember, factoring is the opposite of foiling. So what we're trying to figure out here, if I were to FOIL this out, my f is the x squared. The o and I combine together to give me negative 3x, and the L is the negative 4. So start with the f. How do you get x squared? X times x. Now this is where we jump to the L, because we said I know I'm going to multiply those two numbers and get negative 4, right, for my L. When you take this times this, that's your L. Your last terms multiplied together give you negative 4. But remember, the O and I combine, add to give you negative 3. That middle term. So multiply to give you the L, add to give you the OI. Okay, what are some things that multiply to give you negative 4? Okay, 4 and 1. Now, since it's a negative 4, one of them has to be negative. What? It has to be the negative 4, because negative 4 plus 1 gives me negative 3. So those are the numbers we fill in down here, x minus 4, x plus 1. Keep in mind what we just did. If you FOIL this out, x times x is x squared. 1x minus 4x gives me minus 3x. Negative 4 times 1 gives me negative 4. Okay? You ready so far? Now, what I've done here, I have something times something equals 0. I'm multiplying these two things together, and I get 0. The only way that's possible is the first thing maybe is 0. If this is 0, and kind of ignore the fact that it's parentheses real quick, if this is 0, even if you think about distributing it and be 0x, 0 times 1, it's just be 0, right? 0 times anything would give you 0. So if that is 0, it would work. So I need to figure out if x minus 4 is 0, what would x be? So we're going to set x minus 4 equals 0. We're going to add 4, and we get x equals 4. That's one of your answers. But here's the thing. maybe x minus 4 isn't 0. Maybe this is 0. Because same thing, if you take x minus 4 times 0, it doesn't really matter what x is. If you multiply that set of parentheses by 0, it's going to give you 0. That would work as well. So you have another option. X plus 1, what if that's 0? That would also work. So I need to figure out, well, what would x need to be? So subtract 1. So x could also equal negative 1. There's your two answers. So remember on Monday I said most of the time you're going to have two answers because usually the parabola goes down and back up. But on Monday it was usually like +3 and -3. Not the case today. What this means is you're going to have a parabola that goes down at 4 and back up at -1. Okay? Now to show you that this works, you can check every single one of your answers today. If I plug 4 into my equation, it should work. If I take 4 squared minus 3 times 4, it should give me 4. 4 squared is 16. 3 times 4 is 12. 16 minus 12 gives me 4, right? That one works. If I plug in -1, it would be -1 squared minus 3 times -1 equals 4. -1 squared is 1. -3 times -1 gives me a +3. 1 plus 3? 4. It won't work. So those are your answers. Okay? All right, let's get this glued into page 41. And this is section 9.4, solving by factoring. Okay, so number 1. The first few problems should be really easy. The first one says x minus 5 times x minus 6 equals 0. Okay, so for the most part, these are going to be 3-step problems because we are using the zero product property. So the zero product, that's 2 of your 3 steps. So the first thing, the zero part, has to be set equal to 0. Set equal to 0? Perfect. Product. It needs to be factored. It's factored. Remember, isn't factoring 2 sets of parentheses multiplied together? It's already factored for you! All the hard part's done for you. The only part we have to do now is what I have now is I have something times something. I have these 2 things I'm multiplying together, and I got 0! The only possible way I can multiply 2 things together and get 0, either that first set of parentheses, it has to be 0. Because 0 times, it does not matter what's in that parentheses. It could be 8 billion. It doesn't matter. 0 times 8 billion is still going to be 0. So, if x minus 5 is 0, that would work. That would make the equation true. So if x minus 5 is 0, we add 5, we get x equals 5. That's one of your answers. But that's not the only way this could be true, right? Because what if x minus 5 is 8 billion? If this is 8 billion, what would I need to multiply by to get 0? 0. So then if that's the case, then x minus 6 would need to be 0. One of them has to be 0. So add 6, we get x equals 6. And this one's really easy to check, because if you plug in 5, 5 minus 5 is 0, 0 times, that's 0. Plug in 6, that one gives you 0. X minus 5 times 0, it doesn't even matter what x minus 5 is, we get 0. Okay? I think the first several problems on your homework today are that easy. Okay? Number 2, let's say we have 3n times n plus 7 equals 0. Okay, so we are using the zero product property. So the 0 part is set equal to 0. Perfect. Product. It doesn't look like the last one, right? It's not 2 sets of parentheses. But that's not the only way that a product could look like. A product just means that it's something times something. Doesn't it say something times something? It says 3n times n plus 7. It is two things multiplied together. It looks different, but it is saying two things multiplied together. It's already a product. Those first two steps, just like number 1, are already done for you. Well, here's the thing. Just like the first one. If that first one I circled is 0, 0 times n plus 7, doesn't matter what n plus 7 is, that's going to give me 0. That would work. So, if 3n is 0, that's one option. To solve for n, divide by 3, we get n equals 0. Because 3 times 0 is 0, 0 times that would give you 0. Or, if 3n is not 0, so maybe 3n is 55, 55 times, that would have to be 0. N plus 7 would have to be 0 to make that 0. So subtract 7, you get n equals negative 7. So 0 and negative 7. Questions on either of those two? The first handful of your problems in your homework today are already going to be that much done for you. So make sure you're not working too hard. Okay? Number 3, x squared plus 11x plus 18 equals 0. Okay, remember 3 steps. First step, 0 product properties. Is that equal to 0? Yes. Second part, product. It needs to say something times something. Is it a product? This one's not. This one says x squared plus 11x plus 18. It does not say that. For this to be a product, this one would need to look like this. It would need to say something times something in parentheses equals 0, which means this is where we're going to have to factor. Now these ones are easy to factor because my f is x squared. How do we get x squared? It has to be x times x when you FOIL it out to give you the x squared. Now to get the L, remember those two numbers, when you FOIL it out, that times that is going to give you 18. And also remember the O and I, when you take x times that and that times x, when you combine those, the O and I will add to give you 11. 9 and 2. So it would be x plus 9, x plus 2. That's the hard part today. It's the factoring part today. Okay? Which isn't new. Just maybe a little rusty. Alright, here's the thing. I'm multiplying two things together. X plus 9 times x plus 2 equals 0. The only way I can multiply these two things together and get 0, either x plus 9 would have to be 0, because if that first set of parentheses is 0, 0 times x plus 2, that would give me 0. Or x plus 2 would have to be 0, because x plus 9 times 0 would give me 0. So, subtract 9, x equals negative 9. Subtract 2, x equals negative 2. Okay, number 4. 5x squared plus 9x minus 2 equals 0. Just remember, these are 3-step problems. 0, product, property, 0. Is it set equal to 0? Yes. Product. Is it a product? No. We know what it should look like. For it to look like a product, it should look like this. Which means I need to factor this. Now, looking at this, we may be thinking, okay, well, my f is 5x squared. 5x squared. What method are we going to use to factor this? This is an airplane method, right? Because it's an ax squared. If it's an ax squared, you have to do the airplane method. So let's review how to do the airplane method. Your airplane has to have wings. So we're going to take 5 times negative 2. You get negative 10. Remember, your airplane also has to have a propeller, which is 9. Same as the T-chart before, it's going to multiply to give you negative 10, add to give you 9. Okay, 10 and 1. One of them needs to be negative because it's a negative 10. The 1 would need to be negative because the 9 needs to be positive. Okay, now, for the airplane method, a couple of reminders here. That 5x squared is going to carry almost down here into a 5x and a 5x. You have to start with that. And you're going to throw those numbers at the end, plus 10 minus 1. Remember, that doesn't work because 5x times 5x gives you 25x squared. So you have to land your plane by dividing out common factors. What do 5x and 10 have in common? A 5. Make sure we do the butterfly method. 5x divided by 5 is x. Remember, the 10 is that 10 is negative, but to give me a positive 9 is going to be positive. And then 10 divided by 5 would give me 2. What do 5x and 1 have in common? 1, nothing. Right, so that's just going to stay 5x minus 1. All right, it's set equal to 0. It is a product, so I'm multiplying two things together, and I'm getting 0. The only way that's possible, either x minus 2 would have to be 0, or 5x minus 1 would have to be 0. So to solve this one, subtract 2, x could be negative 2. Solve this one, it's going to be a two-step equation. So we're going to add 1. So 5x equals 1. Divide by 5. So x could also be 1/5. Notice you've been getting two answers every time. Questions on number 4. All right, number 5. A squared equals 24 minus 2a. That's number 5, not 5a squared. Sorry. Okay, remember, we are using the zero product property. Is it set equal to 0? No. Okay, here's the thing. You need to be really careful. When you set equal to 0, your squared term has to be positive. So the whole idea of setting equal to 0 means everything gets moved to the same side, and technically, mathematically, you can move everything to the left or you can move everything to the right. But whenever you're doing these problems, you need to look at your squared term. If your squared term is already positive, you don't want to move it. Although it might be maybe simpler to just move the a squared, it's going to then be a minus a squared. We don't want a minus a squared. I want that a squared to stay the same. So what I'm going to do is I'm going to need to move both of these, the 24 minus 2a, to the other side. So let's move them one by one. How would you move a 24 to the other side? Okay, subtract 24. What about a minus 2a? Add to it. Okay, now, here's the other thing you really need to be careful about. When you move these to the other side, you need to put them in order. Meaning, it should go a squared, the plus 2a, and then the minus 24. You always put your squared term, then your regular term, and then your number. So it's going to be a squared plus 2a minus 24. So when you move them, the square term has to be positive, and your terms have to be in order. Now from here, it's the same as number 3 up there. I need it to be a product. It needs to say something times something equals 0. This one should be the simple one because it's just an a squared. How do you get an a squared? A times a. To get the negative 24, we're going to multiply to get negative 24 and add to get 2. 6 and 4. One of them needs to be negative. If I do a negative 6, I get a negative 2. So it'd have to be a negative 4 and a positive 6, right? Because when I moved that 2a over, it became a positive 2a. So it's going to be a minus 4, a plus 6. Which means a minus 4 could be 0, or a plus 6 could be 0. Add 4, so a equals 4. Subtract 6, a could be negative 6. That factoring part is going to be the part that's the most challenging today. Okay, got just a few more. One more tricky one, and then a couple of kind of special cases to watch out for. Okay, number 6. Number 6 says 3z squared minus 8z equals negative 5. Okay, what's the first thing I need to take care of? It has to equal 0. So, in this case, remember, two things. Your square term has to be positive. My 3z squared, it's already positive, so don't move it. So we're going to move that minus 5 over to the other side. And then remember, you want them to be in order. So it needs to be the z squared, the z, and then the constant. So it's going to be 3z squared minus 8z plus 5 equals 0. Okay, next step. It needs to be a product. So I'm going to have to factor that. And you may notice it's a 3z squared. So what method are we going to use? The airplane method. So we're going to draw our wings, which means we're going to take 3 times 5, which is 15. We're going to draw our propeller, which is negative 8. So things that multiply to give me 15, add to give me negative 8. Negative 3 times negative 5. Multiply to give me 15, add to give me negative 8. Now remember, with the airplane method, since this is a 3z squared, we have to start with 3z and 3z, and then minus 3, minus 5, and then land your plane. 3z and 3 have a 3 in common. 3z and 5 don't have anything in common, so we'll just divide out of 1. 3z divided by 3 would just be z. 3 divided by 3 would be 1. And then when you divide by 1, that's just going to stay 3z minus 5. Okay, now the last step, something times something equals 0. That means either z minus 1 would be 0, or 3z minus 5 would be 0. So if I add 1, we get z equals 1. This is going to be a 2-step equation. Add 5, we would get 3z equals 5. Divide by 3, we get 5/3. Okay, questions on those ones so far? Most of your ones today are going to be more like numbers 1 through 4. So they're either going to be factored for you, or they're already going to be set equal to 0 for you. We'll throw more of those in tomorrow. Okay, now there are a few that you need to just watch out for that are actually so much easier than the ones we just did. But they're the most missed questions. So, okay, number 7 says 3b squared equals 9b. Okay, first problem. Okay, it's not equal to 0. Okay, remember, your square term needs to be positive. It's already positive. So I need to move the 9b over. So I'm going to subtract 9b from both sides. Now be careful here. 3b squared minus 9b, are those like terms? No, one's a b squared, one's a b. They're not like terms. So you have to leave it 3b squared minus 9b. Okay, now it needs to be a product. But this one looks different than the other ones because there's not 3 terms. This isn't going to be a foiling problem. This is a greatest common factor problem. What do 3b squared and 9b have in common? A 3 and a b. So we're going to write the 3b on the outside. And when I factor out a 3b, we'd be left with b minus 3. So either 3b equals 0 or b minus 3 equals 0. Divide by 3. Sorry. We get b equals 0. Add 3, we get b equals 3. We may add a couple more tomorrow.